Hi everyone. Today we are going to discuss solutions, its components and types. This is a very important concept, provided foundation for many other chemical processes. Let us start it. Consider we have two flasks, X and Y. If we observe carefully, we will gauge that flask X has uniform composition thoroughly. It means that from top to bottom and from left to right, there is not even minute change in the composition of flask X. Moreover, it seems to be in a single phase. Solution has both characteristics, and therefore the flask X is a solution. Now consider the flask Y. The composition is not seemed as uniform. Furthermore, this has two phases, solid and liquid. Thus, flask Y is not a solution, rather a mixture. So at this stage, we have a clear idea about a solution. The next question raised in our mind is that what are the components of a solution? So let them explore. A solution is made of two components, solute and solvent. For example, a salt solution contains salt as a solute and water as a solvent. Now another confusion is that how to distinguish between solute and solvent. It is so simple. The substance that is dissolved in the solvent is solute. It is usually taken in lesser amount, while the substance that dissolves solute in itself is called solvent. It is usually taken in larger amount. There might be more than one solute, but solvent remains single. Like in the case of tea, if milk is in greater quantity than water in a teacup, water, sugar and tea are solute while the milk is solvent. Now come to types of solution. Types of solution is a very detailed subject. Here we are going to discuss types of solution based on physical states of solvent and solute and amount of solute added. First, let us discuss the types of solution based on physical state of solute and solvent. This is very comprehensive. These are total 9 in number. We discuss them briefly here. First, if solute is gas and solvent is also a gas, then solution type is gas in gas. The example of this solution is air, where O2 is present in other gases like N2 and CO2, etc. Second, if solute is liquid while solvent is in gaseous state, then solution is liquid in gas. An example is fog, where liquid droplets are suspended in air. Third, if solute is solid and solvent is gas, then solution is solid in gas. An example of solution is smoke, where dust particles are suspended in air. Dust particles are solid and therefore these behave as solute. Next, solution is gas in liquid. Solute gas and solvent liquid. The best example is of carbonated drinks like Coca-Cola and Pepsi. Fifth, liquid in liquid. It is mostly used and common in practices. Example is vinegar in water, benzene in ether, etc. Next is solid in liquid. These solutions are also widely used like salt in water, sugar in water. Finally, those solutions in which solvent is in solid state. First, gas in solid. The example is pumice rocks, where air entrapped in hollow spaces of rock. Second, liquid in solid. An example is dental amalgam, where mercury that is in the liquid state is mixed in solid silver. And last one is solid in solid. And the example in this context is metal alloys like brass and steel, as brass is composed of copper and zinc metals, and both these metals are in their solid state. Now move to second criteria for classification of solution. It is based on amount of solute added. Another means concentration of solute. It is very significant. First, consider a very technical concept. Suppose I have 10 gram of salt and I have added it in 100 milliliter of water. It forms a solution. Now I make another solution in which I have added 20 gram of salt in the same amount of solvent. On the relative basis, I can observe greater amount of solute in second solution comparison to first one. Thus, first solution will be known as dilute solution as comparison to second solution, that is concentrated solution. So a solution that contains relatively larger amount of solute is called concentrated solution. So this was difference between dilute and concentrated solution. So let's uncover it in another way. If I fix the temperature like 25 degrees Celsius, at this temperature I added 30 gram of salt in 100 milliliter of water. Then I observed that this amount of solute is dissolved. If I wish to add 5 gram more, it can also be added at this temperature. Thus, such a solution that can dissolve more amount of solute at a given temperature is called unsaturated solution. While on the other hand, if I try to add 5 gram more in the solution that already contains 35 gram of solute, I will not be able to dissolve that amount. Some of the added amount will be settled down. At this point, when no further solute can be dissolved in a solution at a given temperature, the solution has become saturated solution. However, this extra amount that is settled down in a saturated solution can be dissolved on heating. It means that solubility of several substances increases with increase in temperature. We will discuss this effect in another video. Come back to the scenario. If I heated saturated solution, the settled amount of solute will be dissolved. Even more amount of solute can be added. Thus, a solution in which excessive amount of solute is added, which is more than amount of solute in its saturated solution, is called supersaturated solution. These solutions are prepared in crystallization process to purify substances. Hence, excess amount of solute can be recovered through the process of crystallization. This is all for today. Hopefully, this would have clarified your concept of solution and types of solution, primarily saturated, unsaturated, and supersaturated solutions. For more animated lectures, for exploration and discussion of basic concepts, subscribe our channel and press the bell icon.